All right, just want to start working on this. Uh, First part is cracking the coding interview, and 189 programming questions and solutions. Tracked her down. She lives in Palo Alto. Went up to Seattle for a little. Didn't like it. Had an internship with Microsoft before that. That's probably why she went up there to Seattle. Obviously didn't like it. She founded some company, started working for herself, and she was like, well, now it's probably, scene is not up there in Seattle, which is what I say all the time. And she's in Palo Alto. Anyway, this book is really popular with foreigners and Americans, who did not specialize in computer science in university. They're trying to do a career change to tech and to FANG, get a FANG job. This is one of the books suggested all the time. So now you can see right there at some Microsoft cracking the tech insider advice at. Interesting how this was laid out. What's this? This is a 2016. I think it was published in 6th edition. 2015, 2016. Career Cup, published by Career Cup, is actually her company, LLC, in Palo Alto, and she lives in Palo Alto. Not surprised. That's where Stanford University is. That's where I live also, and the beginnings, the starting of Silicon Valley itself, before everything was Stanford University. And then out from Stanford came Silicon Valley. Out of Stanford came Cisco, and many other things. So I want to start reviewing this book. I only get 15 minutes in this video, so I'm going to start jumping in. I will be hitting the lead code problems, starting with the easy, and then when the easy are too easy for me, all the easies are too easy, then I will move to intermediate. When the intermediates are too easy for me, then I will start applying to jobs. This is the advice I was given by a really good software engineer that learned from scratch how to get into the industry. He was a mathematics master degree holder. So, intro, the interview process, behind the scenes, special situations, before the interview, behavioral questions, Big O. Big O is time, space, complexity. Very important to understand anything I'm doing with that. Technical questions, the offer and beyond, interview questions, data structures. Data structures are important to understand the algorithms. The algorithms are the meat of the problem solving, and Fang wants you to know how to solve problems. There are pre-designed methodologies to solve problems, and that is the algorithms that they have here. So most of the problems that they have, they'll have some new situation of things, or maybe it's an old situation to work on, but they will expect you to know some algorithms, some old algorithm, or hybrids of algorithms, mixes of algorithms to solve the solution. So whatever new situation it is. So we're using the same old algorithms and on new situations, and that's what we should look for. So the concepts and algorithms, I'll look deeper into this. So we've got bit manipulation, math and logic puzzles, object-oriented design, recursion and dynamic programming, system design and scalability, sorting and searching, testing, and then with knowledge base. Let's go to again, additional problems, solutions, advanced topics, code library, hints about the author. So that's it about that. So I will go deeper into read into the subsections now. So we've got how questions are selected. It's all relative. FAQ. the Microsoft interview, the Amazon interview, Google, Apple, Facebook, Palantir, whoever that is. Palantir and Microsoft are not as common, but notice this, MAGA, M-A-G-A, it's actually FANG, but and this was 2015, 2016, so I'm pretty sure there's a correlation there. So special situation experienced candidates, testers and SDETs, product and program management, dev lead and managers, startups, acquisitions, and acqui-hires. For interviewers, so she specialized in the interview and now she's in specializing in product management or project management, like this one here, product program management. Even though she's claiming software engineering, but she's really reflecting project management right now. Actions speak louder than words. That's what I say. So before the interview, getting the right experience, writing a great resume, preparation map. Getting the right experience. Interview preparation grid, know your technical projects. Responding to behavioral questions. So tell me about yourself. This is really everything to expect. This is important to have show the right types of projects, and then the what types of behavioral questions. If you know what they will say, if you appear that you're used to the interview, then they like that more, and more likely to pass the interviews. Big O, an analogy, time complexity, space complexity, drop the constants, drop the non-dominant terms, multi-part algorithms, adverse multiply, amortized time, log-n runtimes, recursive runtimes, examples and exercises. So again, big O, time space complexity is everything you're doing. You should know the time space complexity, so you can select the optimal state for the problem solving. How to prepare, what you need to know walking through a problem, optimize and solve technique, look for BUD, optimize and solve technique. Number 2, DIY, simplify and generalize, base case and build, data structure brainstorm, best conceivable runtime, handling incorrect answers, when you've heard a question before, the perfect language for interviews, what good coding looks like, don't give up. So, writing good coding, repeat problems. So you're going to use the same algorithms. You learn a set of algorithms and use the same algorithms to solve all different types of situations, whatever new situation comes up. So that's how you approach it, and whatever BUD is. I want to check this out. BUD 67. Also, a good question is how she is qualified to, how she knows all of this. How is she became qualified to write this book. So you go to 67. What is BUD? Bottlenecks, unnecessary work, duplicated work. This is perhaps the most useful approach I've found for optimizing problems. BUD is a silly acronym. These are 3 of the most common things an algorithm can waste time doing. So I'm reading, this is a very simple book to read, and it seems like it's like one of those PCs for Dummies books, but it's brute force itself. It's talking about brute force, but it has a brute force feeling to it. So kind of barbaric methods, but into the problem, tear it up, and be finished with it, be done with it. So this is like, why is big O important? You can tell here it's because it's creating bottlenecks. Identify the bottlenecks. To do that, you have to know the big O, time, space, complexity for each part of the problem. This book has pretty good advice, so I think this is good to read before doing the lead code problems, so I understand why I'm doing it, what to look for. So as you can see here, it's by solving the bottleneck, it's solving through using the algorithms together. So it just says here, we now have a 2-step algorithm where both steps take O and log n time. Now sorting is the new bottleneck. Optimizing the second step won't help because the first step is slowing us down anyway. We just have to get rid of the first step entirely and operate on an unsorted array. How can we find things quickly in an unsorted array? With the hash table. So they're saying it's not many parts. There are not many data structures. And we're working through algorithms that we already know and data structures that we already know to streamline it from the start and work through the bottlenecks, optimizing it through the process that works through the bottlenecks. And we have a limited set of tools, so we know what our tools are. The only tools we can use to solve the bottleneck. So we compare all the tools and see which ones are going to cause least a problem. Use those. So I was just reading part of this, and algorithms is the most learning how to use algorithms is the most important part of computer programming, software engineering, and so as far as this BUD, her explanations on how to use algorithms it's very good. It's very intuitive. So I like that very much. I think it will be very easy, pleasant to understand book to read, and help me a lot to understand algorithms also, which is my first love. Speaking of which is concepts and algorithms. So yeah, of course you can see the data structures compared to the algorithms section. Let's do that first. We've got page 88 to 107, 112. That's 24 pages. And the algorithm section is about 46 pages, 112 to 158, so that's almost double the size. Including there are 4 chapters for data structures and 7 chapters in algorithms. So that is to say that the algorithms are much more complex formal information, and the data structures are, just components that make the algorithm. So that makes total sense. Next videos, I will continue to focus on the whole book, but also the algorithms in particular. So for now, let's take a brief look into algorithms more. Bit manipulation, math and logic puzzles, object-oriented design, recursion and dynamic programming, system design, scalability, sorting and searching, testing. Bit manipulation by hand, bit facts and tricks, to use complemented negative numbers, arithmetic versus logical right shift, common bit task, prime numbers, probability, start talking, develop rules and patterns, worst case shifting, algorithm approach. So a person should ask, why did she choose these? These are obviously the most common tools needed. How to approach design patterns, how to approach recursive and iterative solutions, dynamic programming, memoization, handling the question, system design and scalability, handling the question, design step-by-step, algorithms that scale step-by-step, key concepts, considerations, there is no perfect system, example problem, sorting and searching, common sorting algorithms, searching algorithms, testing what the interviewer is looking for, testing a real-world object, testing a piece of software, testing a function, troubleshooting questions. So I've heard many times of people just picking up this book and later they take interviews and they do very well and sometimes get a job. So combined with LinkedIn, but this book definitely provided them with some support, a lot of support. So I'll be looking at this further. Personally, I hate Java, but I do see it a lot around. We do have C++. My second language would actually be C++, but yeah, I'm actually a Python person, Python developer. So I think algorithm is another term for analyst. So analytical ability here actually means algorithms, algorithmic ability. And I continue to see that algorithm. So it says here, Google puts a strong focus on analytical algorithms. You should be very well prepared for these questions. So there's a lot of weight to put on the analytical ability, the algorithmic ability. So that's very good. And I'll be looking at that more.